This is the second video about object-oriented programming with Gradual Abstraction in an experimental programming language called ASL2. Again, I recommend that you read the accompanying paper with this title. In the previous video, we illustrated ASL2 non-classified objects. In this video, we will proceed on the abstraction chain to weakly classified objects. We have started the ASL2 interpreter, which runs was implemented in Scheme, and it runs here in Emacs on a Windows machine. I pre-programmed an example, and I'm ready to show it in the running interpreter. The example here is very similar to the one shown when we discussed non-classified objects. Here we will create similar points, here called P3 and P4, located as shown here in a coordinate system. So let's go for that. First we define P3. And the crucial difference between what we have shown before is that now the object has a role. It's weakly classified as a point. So this can be thought of as a role name or a tiny bit of documentation. We understand this object with these two x and y field as a point. It's just a simple text string which says this is considered as a point. So P3 and similar P4. Now let's add a member function, the distance2 function, which we also did in the other example in the other video, and it's a simple distance between 2 points calculated in this way. Now we can ask for the distance between the receiver P3 and the point P4, and we get the result as before. When we worked with non-classified objects, we were forced explicitly to borrow the method from P3 to other objects. This is not necessary here because when we worked with weakly classified objects, there's automatic borrowing, so to say. So when I send the distance2 method to P4, it looks in the neighbor object P3 and accesses the distance2 method in P3. So because both P4 and P3 are points, we support this method borrowing. This is a primary thing about weakly classified objects in ASL2. We can also add these angle methods. We added to P4 here, and we add the radius method to P4. And of course we can get the angle and we can get the radius, but these also apply on P3 because we have the similar automatic borrowing of objects between objects of the same role. So this actually ends this branch of the demo. We will continue our example on weakly classified object on a slightly different scene. We will create points P, Q, and R, and we will define line segments, which are other kinds of objects. 2 line segments, and we will end up with definition of this triangle. So we will work with points, line segments, and triangles. So we are ready to start on this example, and we start by the point P and the point Q and the point R. And the next thing, as we have seen several times now, is definition of a distance2 method, which we put into the P object. But because we are working with weakly classified objects, they're all classified as points, they can borrow the distance2 method from each other, which is quite convenient in that situation. So it means in reality that the distance2 method is available on all 3 points. Let's proceed to line segments. So these are objects of another role, a line from P to Q. So there are 2 fields, P1 and P2, which are points, which represent a line segment as an object. Was one line segment and another line segment from Q to R. Now let's use the distance2 method to define the length of a line segment. We put it into line PQ and try it out immediately. And due to the use of borrowing of method between weakly classified object, we can also use it on the other line segment. We now come to the triangle. So we will define this triangle, and we will care about a number of methods which do useful general calculations on this geometric object, a triangle. So we first define T1, the first triangle, with 3 corner points, C1, C2, and C3. So P, Q, and R becomes the corner point of this weakly classified object, which is a triangle. Now we define a method, the circumference method, which adds the length of the distances between the 3 corner points. So there are three lines, and we calculate the distance between C1 and C2, C2 and C3, and C3 and C1, and we add these. This becomes the circumference method, and of course we try it out immediately. The circumference is 33.02. The next thing we do is that we want from the triangle T1 to have a method which returns the line which opposes a given corner. So if this method is used on this corner, we generate and return this line segment. We use this line opposing method in the most complicated method we will deal with in this little video, which is the angle method. It's a method which calculates the angle, one of the angles in the triangle, with the use of the so-called cosine relation. So internally, in order to do that, we construct the 3 line segments, and we calculate their length, and we do the calculations at the bottom in the 2 inlets. So we defined the line opposing method up here, and we use it internally, and we also use the length method internally in our angle method. And these are all methods which happens to be defined in a particular object, and by means of borrowing as used for weakly classified objects in ASL2, they are provided to the other objects. Now we have the angle method. Let's define a method called angle sum, which adds the angles of a triangle. And of course, we expect that when we send the method angle sum to an arbitrary triangle, that we get something which is very close to 180 degrees, and in fact we get that. Let's here at the end also construct yet another triangle T2, which has the corner in 0.0, and 2 other corners as shown here. So this is in fact the little green triangle located here. Before we worked on the red one, the bigger red one located here. So now we have the 2. Let's try it out. The circumference is calculated, and the angle sum, which again, of course, in order to be correct, must be very close to 180 degrees. So in this video, we have made a couple of points. We have put particular methods in one of the points. The points are weakly classified. All our objects are weakly classified as either points, line segments, or triangles. And by means of this idea of borrowing between objects that have the same role, we have succeeded this geometric construction task. The next abstraction step that we care about is generation of class objects, so stay tuned for the next video. Thank you.